Now the next type of congruency rule which you're going to learn is about SSS congruency rule. Let's see the triple S congruency rule as connected with the branch of mathematics. As can be clearly seen that SSS refers to all the three sides of the two triangles. It doesn't take into consideration any angle but only the sides, is how we understand the rule initially with SSS congruency rule. So let's take two triangles. Triangle ABC and triangle DEF. Here, let me say the side AB equals side DE. One pair of side is equal. Let me go to the second pair of sides. BC equals EF, and the third pair, which reference with third S, is AC equals DF. Then triple S axiom or triple S congruency rule states that if the corresponding sides of the two triangles are equal, then the triangles must be congruent by SSS. AB equals DE, BC equals EF, AC equals DF. The first side, second side, and the third side. So if the corresponding sides are equal, then by triple S axiom, triangle ABC must be congruent to triangle DEF. Is how I understand the two triangles being congruent through the side axiom. So let's write this in statement. If the corresponding sides of two triangles are equal, then the triangles must be congruent, is how we understand the triple S axiom connected with the two triangles being congruent. Side axiom. Now that we have seen the various types of axioms which prove the congruency of two triangles with their own respective rules and properties, now let's see exclusively when we consider two right-angled triangles. The congruency proved through the properties using for two right-angled triangles. So the RHS axiom derived for two right-angled triangles. RHS. R stands for right angle. H stands for hypotenuse. And S stands for one side other than the hypotenuse. So right angle, hypotenuse and one side of a triangle are taken into consideration in proving the congruency of two right angled triangles. So let's see the RHS axiom connected with congruency of two triangles. Imagine I have two right angled triangles. Say I consider the right angled triangle ABC and the right angled triangle DEF. This is right angled at B and this is right angled at E. Now imagine I have my angle B which equals angle E, which are right angled, and clearly my hypotenuse here is AC because this is opposite to 90 degrees. So AC is the hypotenuse for the first triangle and FD is the hypotenuse for the second triangle. So if the two angles are right angles and if the hypotenuse are equal and one side which is equal, say my BC is equal to ED, then by right angle, hypotenuse and side, right angle, hypotenuse and side, I can say that the two triangles are congruent. If angle B equals angle E, which is 90 degrees, and my hypotenuse AC equals my hypotenuse FD, and my side BC equals my side ED, by RHS axiom, I can say the two triangles are congruent. Then by RHS axiom, triangle ABC is congruent to triangle DEF, is how we understand the RHS axiom. Two triangles congruent when they are connected with RHS axiom. Let's see in words. RHS axiom. If in two right angle triangles, right triangles, the hypotenuse and one of the sides are equal, the corresponding hypotenuse and one of the sides are equal, then the two triangles must be congruent, is how I understand the RHS axiom. If in two right triangles the corresponding hypotenuse and one of the sides are equal, then the two triangles must be congruent, is how we understand RHS axiom. Right angle, hypotenuse and one of the side being equal makes the two triangles congruent to each other. Now that we have seen the different types of congruency rules, let's investigate what if the corresponding angles are equal. As we have seen, the triple S rule where if the corresponding sides are equal in the two triangles, then the two triangles are congruent to each other. Similarly, will the two triangles be congruent if their corresponding angles are equal? Is the biggest question in the session. So let's investigate AAA rule for congruency of two triangles. AAA rule. What is AAA rule? AAA stands for all three angles of the triangle. So imagine I have two triangles A, B, C, and I have another triangle D, E, F. If my angle A equals angle D, angle B equals angle E, and my angle C equals angle F, then will the two triangles be congruent? We can clearly see that if the corresponding angles are equal, then the two triangles may not be of the same shape. We can just draw random triangles using a protractor and the ruler and check if we can have the same angles and different sizes of the triangles. Just like here, the angles are equal, but the triangles are not of the same shape, clearly indicating that these two can never be congruent, never be equal in all respects. Therefore, if angle A equals angle D, angle B equals angle E, and angle C equals angle F, then by AAA rule, triangle ABC is not congruent to triangle DEF. It is very important to note the corresponding angles equal implies the two triangles need not be congruent. Therefore, if corresponding angles are equal, then the two triangles need not be congruent. Not always. Only few times the triangles are congruent depending on their respective lengths, but they are not always congruent. Since the two triangles form a different size, though their respective angles are equal, is one of the biggest mathematical property which should be noted. The reason being that since the two triangles form a different size, though their corresponding angles are equal, they form a different size, this being small and this being big. Or any triangle which is so smaller in size and so bigger in size will have the same common angle, but they are not congruent to each other. The two triangles have corresponding angles equal, but they are not congruent to each other, is how I understand the learning outcome of AAA rule. Congruency connected with AAA rule. Angle, angle, angle rule.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.